Number 27. The perimeter of an equilateral triangle is 852 centimeters. The three vertices of the triangle lie on a circle. The radius of the circle is w square root of 3 centimeters. What is the value of w? Right, couple of things right off. I'm always going to draw what I am given first. So I know I have a triangle, an equilateral triangle, and it's inside a circle. So, okay, I got my circle. And let's see if I can pull this off. I'm going to have... Come on. That's not bad. It's not the best triangle I've ever drawn. It's not a perfect equilateral, but it is close enough that we can know what's going on. Right, so the three vertices lie on the circle. And what are we given? We are given the perimeter of the triangle. We know that that's 852 centimeters. And we know the radius of the circle is w square root of 3 centimeters also. Right, so what do I know about equilateral triangles? Equilateral triangles all have congruent sides. They're all the same. They also have congruent angles. Each one of these angles is 60 degrees. These are equilateral triangle facts that you definitely should know. If you didn't have that in your data bank, please add it there. Remember it for the SAT. Comes up a lot. Okay, so I have this triangle. Do I know anything else about it? Well, I know its perimeter is 852. Because of that, I can figure out the length of each side. All three sides are the same, so 3 times the length of one side would be 852. So to solve for that, s is being multiplied by 3. So I want to undo that. I want to divide by 3. So I get that s is equal to 284. So 284 centimeters is the length of each side. Okay, that's good to know. Now, when they tell us the radius of the circle is w square root of 3, anytime you have a triangle and you have square root of 3, you have a problem with the triangle and square root of 3 is mentioned, I want you to immediately think, is there a way I can use 30, 60, 90 triangles? Have that pop up in your head. You may not, but the odds are in your favor. It's going to be a 30, 60, 90. Just the way it works. Now this pattern, that's we have observed in the 30, 60, 90 triangles that they ask you to memorize, it is provided by the SAT board, the College Board. You can see it, but you have to know you need it. And that's why I ask people to memorize it. Because if you memorize it and you know what's in it, then you are more likely to recognize when you need to use it. Just, trust me on that. So the pattern is like this. The leg that's next to the 60, you can represent with x. The hypotenuse is 2 times that number, or 2x. And the leg next to the 30 is that number times the square root of 3. And that's the pattern it follows. Likewise, if you see square root of 2 related to triangles, I immediately want you to think of 45, 45, 90 triangles, which are a square root of 2. Those are the patterns, and it's just really good to have those in your head so that, again, when you see a square root of 3, a square root of 2, your mind's going to go to that and see, can you use it? And a lot of times you can. All right, so we're looking for 30, 60, 90 triangles. We don't have it yet, but we do have these 60 degrees. And what happens if I draw some radii in here? So that's about the center of my circle. So if I draw a little radii out to the corners, it's rough drawn, but you get the idea. What am I doing? I am dividing this triangle into 3 congruent triangles, 3 congruent smaller triangles. And I'm also splitting each of these 60-degree angles in half. So now I've got each of these is going to be 30 degrees. Each of those is 30. And this is true all the way around. Each of these little angles is 30 degrees. But I still don't have a 30, 60, 90 triangle, do I? Not yet, but I'm getting there. I'm getting close. I've got 30s now. I have bigger triangles that I can make, this big triangle that has 60 degrees. What would happen, I'm going to use a different color for this. let's see, what would happen? Oh, let's go orange. If I extended these radii, it doesn't look that different, does it? Let's use baby blue. That'll be different. Okay. What would happen if I extended these radii? And if I had drawn this all perfectly? Well, then I have split those triangles yet again. I've cut them in half. So it should be 6 congruent triangles now instead of 3. I've cut them all in half. And each of these I've drawn, these are altitudes, meaning it's creating a right angle here. It's an altitude for this triangle, an altitude for this triangle, an altitude for that triangle. So it's creating right angles. And now, my friends, we've got our 30, 60, 90 triangles. So like, for instance, if I just looked at this triangle right here, I can see I've got my 30 degrees right there, got my 90 degrees. So the other remaining angle must be 60 degrees, always. Do I have any lengths of these sides? Well, I know the radii are all 3 square root of 3. So this particular radius, excuse me, not 3 square root of 3, w square root of 3. Oh, forgive me. W square root of 3. And do I know the length of either of these two sides? Yes, I do. I know the length of this side because I know this whole thing is 284, and I just cut it in half into 2 equal bits. So 284, divide that by 2, and I get 142. So now I have this smaller triangle, which is a 30, 60, 90 triangle, and I know one of the sides is 142. Once I have a number, any number, I can determine all 3 sides using this formula. So I'm going to bring this down over here. I'm going to keep it just like it is. So there's my 30 degree. There's my 60 degree. This side is 142. And this side is w square root of 3. Right, so does it fit this little thing? Yes, it does. How does it fit it, though? We have to be very careful. We don't want to just see this square root of 3 and think, oh, that's that side. It isn't. We have to go by where the side is relative to that right angle. This w square root of 3 is the hypotenuse. It's correlating to the 2x. This 142 is correlating to the x square root of 3 because it is the leg, that is, it's touching the right angle. Those are the 2 legs, the ones making the right angle, and it's the leg that's touching the 30 degrees and the right angle. That's how I always remembered it, is it's the square root of 3 is the leg with the 30. That's how I connected it. Yeah, this one has to be the smallest because it's just x. Here you're multiplying it by x times a number which is smaller than 2. And then this would be the biggest number, x times 2. So the biggest number would have to be the hypotenuse. Okay, where do the other 2 go? The square root of 3 goes by the 30. That's what helped me remember that. All right, so that 142 is x square root of 3. So I need to solve for x. Well, let's do that then. So we'll say this over here, that x times the square root of 3 is equal to 142. I need to undo what's been done to x. X has been multiplied by the square root of 3, so I need to divide by the square root of 3. Now I get that x is equal to 142 divided by the square root of 3. We cannot leave a radical in the denominator. It is not allowed. You go to math jail. Not really, but your teacher gets very mad and you get the answer wrong. So we have to get this radical out of there. How do we do that? We're going to multiply by that radical over itself. 2 reasons for this. 1, any number over itself except for 0 is equal to 1. So square root of 3 over square root of 3 is equal to 1. And we can multiply any number by 1 and not change it. That is the identity theorem. A little rusty on that name. Pretty sure that's it. You can multiply a number by 1 and it won't change it. So, okay, I'm not changing anything by multiplying it by square root of 3 over square root of 3. And when I do this, this on the bottom is going to get rid of the radical because the square root of anything times that square root equals the original number. works for any number. You know, like square root of 78 times square root of 78 is just 78. So when I do this, on the top, I am going to get 142 times the square root of 3, and the bottom, square root of 3 times square root of 3 is just 3. So now I look and see, can I simplify this any further? Does 3 go into 142? It doesn't. Quick little way to do that is you can add up the numbers that make up a number. 1 plus 4 plus 2. That's 5. 7. Is 7 divisible by 3? No, then the whole big number is not. Shortcut, multiplication. That's this little, yeah. So I can't simplify this any further. It is what it is. So this is 142 thirds times the square root of 3. That's my x, because this could be square root of 3 over 1, and that's why I can pull it to the side. So 142 thirds square root of 3 is, that's my x. That's my x. So then what is this over here, which is the hypotenuse, these two being the same? I know my x is that, so my hypotenuse is 2 times x. Okay? That's x. What's 2x? So I need to multiply this by 2 to find out what 2x is. So 2 times 142 thirds times the square root of 3. So 2 over 1. 2 times 142. Well, we actually already know what that is, because we divided 284 to get to 142. So 2 times 142 is 284. And I just keep running out of room. It just keeps getting smaller and smaller. And 284 divided by 3 times square root of 3. And is 284 thirds divisible by 3? No, it is not. Same little trick. 2 plus 8 plus 4 is 14. 14 is not divisible by 3, so it's not. So that's it. That's my hypotenuse. My hypotenuse is 284 thirds times the square root of 3. So when they said the hypotenuse, which we mentioned is the radius of this circle, you know, it's both. The radius is w times the square root of 3. What is w? W is 284 thirds. That is your answer. And you can also write this as a decimal. The College Board will accept either 94.66 or 94.67. Yeah, there's a lot there. And this is one of those problems that I can't really see a way that Desmos, like graphing or something like that, would be of much help. It really is relying on your knowledge of 30, 60, 90 triangles and radii and inscribed triangles and all that good stuff, and how to use that to solve. There you go. 284 thirds is your answer, and you have reached it. You have made it to the end. Congratulations.